Okay, so we've taken a look at this. We've got it driving. It's attacking. It's finding that red bottle without a problem. It's still a little bit jittery, and I think a lot of that is because we're still just using the basic drivetrain controls. We talked about when we're doing the driver control that the drivetrain controls work quite well for just the driving of the base, but when we start getting into fine movements, they are a bit problematic. So there's other ways that we can go about doing that. So what I'm going to do in VEXcode, I'm just going to get rid of all of my drivetrain commands that I've been using. And I'm going to go into my devices, grab my drivetrain, and I'm going to delete it. So goodbye drivetrain. I'm going to add 2 more devices. So I'm going to add a motor. Now I just got to remember which right and left here. So my left motor on this side is plugged into port 1, and my right motor is in port 2. So we click on that. This is left motor. Done. And add a new device. Motor. It's going to be in port 2. And this is my right motor. Done. So I've got 2 motors now. Which is cool. I'm going to come back here. And I'm just going to do a test and make sure that these are working properly. So I'm just going to pull that away for a second so it doesn't run. Go to motion. And let's say spin left motor forward 90 degrees. And spin right motor forward 90 degrees. So it's just going to drive forward very quickly. We'll download that to the robot and hit play, and we're just looking to make sure they both go forward. If one doesn't, we have to invert it. So it looked like the left motor that went first went backwards and the right motor went forward. So let's check again. Left, right. All right, so I'm going to come back in here. I'm going to go back to my left motor. I'm going to reverse it and click done. So now I know that it's going to go the right way. We'll download that to the robot again. Hit run, left, right. So we know both motors are working the way that they're supposed to be working. All right, cool. So we'll come back in here. I don't actually need those anymore. That was just to make sure that things were working the right way. And I can drop this back in. So all right, so pretty much the vision system is actually going to be staying relatively the same. It's how we manage those motors. So I am going to say we're going to spin. So if the object is out on the right hand side of the screen, we want to turn to the right. So I'm going to say, this is a bit counterintuitive, the left motor is going to go forward. So if you go, left motor goes forward, robot turns to the right. And I'm also going to say stop right motor for the time being. And then the other way, we're going to spin the right motor forward. We're going to stop the left motor to go forward. We're going to spin both the right and left motors forward. And at the end of our code, we're going to stop the left and the right motor. So we're just breaking it down a little bit. All right, I might have my left and right mixed up. That seems to happen often for me. So let's see what happens. I'm going to download that to the robot. And I'm going to hit run. And you can see just a bit faster now, because when you're using the driver control, or sorry, the drivetrain functions, what it wants to do is reverse one side when it turns. But by reversing a side, you're actually pushing the robot too far. This way, the robot's it's easier for it to self-calibrate and get into the right position. The other thing we can do here too is play with the speeds a bit and see what happens. So I'm going to set I'm going to set my velocity. So we're going forward. Let's set left motor velocity, let's say 70%. And we'll set that 70% when turning. Just notice I didn't do that right. That is the right motor. And when we're going forward, let's go 90%. Just do that through here. Right motor, 90%. So this should be actually a bit faster. Let's see how accurate it is. So from here, if we go run again, let's get the camera a bit better first so you can really see it. Alright, so if I go run, it's a lot faster, it's rectifying a lot quicker, and it's moving into the right spot. So you're getting a lot faster movements. So come back, pull the robot back where we were just starting, and let's shrink that camera back down for you. You can see, like, just in my house here that the light is changing quite a bit. There, you can see some wheels on a robot. And the light's changing quite a bit. Now, this is working, but there is a level that we can go just a little bit further on this one. With those velocities, we could have an equation in here that's using the distance from the center to adjust your speed. So right now I've got velocity 70 going through, but the further away that this is from the object, the faster I probably want it to go. Now, what we know is that on our Cartesian plane, we've got a high of 315 and a midpoint of 157. So when it's the furthest away, if we said 315 minus whatever that value is, we're going to get a fairly big number. So operations, I've got subtraction here. Sensing, find our vision. So vision sensor minus 157. With that, as it gets closer, the slower it's going to go. Nope, I put that in the wrong one. We want to put that in the greater, it's not there, in velocity. There. So now, as it's getting closer to that 157, it's slowing down. Now, the same way with the velocity in the other one, this one here, if we said 157 now, minus that value, it's going to do the same thing. So it'd be faster from one way to the other. So with that one, let's download. And I might have this totally wrong, but let's see what happens. So much, much faster. Now it did knock the bottle down in the end, so it could use some refining. But you can use a bit of math like that to really speed up and get this sorted perfectly.